Hey everyone, and welcome to this explainer. You know, if you're making the jump from Windows over to Linux, or honestly, even if you're just getting started and trying to figure out where the heck all your files went, I know exactly how you feel. It can be incredibly confusing at first. But don't worry, because today we're going to clear all of that up. We're taking a guided tour of the Linux file system. And by the end of this explainer, you're going to see that instead of a scattered mess, Linux actually uses this beautifully logical, unified tree structure. Once you understand the trunk and the branches of this tree, I promise you everything else just clicks right into place. Okay, let's dive right into this fundamental paradigm shift. Looking at the traditional Windows setup, you've got your C drive, maybe a D drive, perhaps an E drive for a USB stick. They're entirely separate, scattered entities. But looking at the Linux side, Linux doesn't do drive letters at all. Instead, it has one unified tree. Every single file, folder, hard drive, or plugged-in USB stick branches out from one single starting point. We call this starting point the root directory, and it's simply represented by a single /. Here's our roadmap for today. First, the root and the tree. Second, users and essential tools. Third, we'll step into the system engine room. Fourth, the whole everything is a file concept. And finally, storage, software, and boot. It's a finite logical space, and we're going to master it step by step. All right, let's start right at the very beginning with Section 1, the root and the tree. The root, which is represented by that single /, is the absolute base. It's the trunk of our entire Linux file system tree. And here's the kicker. It literally doesn't matter if a file is stored on your main solid-state drive, a secondary hard drive, or some removable flash drive. In the Linux world, all of those physical devices are grafted directly onto this single, unified trunk. Everything, and I mean everything, connects back to this one /. Because everything starts at the root, we need to talk about how we write down the address, or the path, to our files. There are two ways to do this, and grasping this right now is going to save you a ton of headaches later in the terminal. First up is the absolute path. This always starts from the root trunk, that /. So /home, /Alex, /documents. It's the full address from the absolute bottom of the tree. Then you have the relative path. This one just starts from whatever branch you're currently sitting on. So if you're already hanging out in Alex's home folder, you just type documents without that starting /. Okay, moving right along, let's climb slightly up the trunk for Section 2, users and essential tools. Directly branching off that root trunk, we have two incredibly important folders. First is /home. If your name is Alex, your personal space is /home/Alex. This is where your downloads, your music, your documents, and personal settings live. It's basically the exact equivalent of the users folder in Windows. Right next door to that is /bin. Think of this as the essential system toolbox. The absolute basic building blocks of Linux live here. I'm talking about the actual binary programs you need to use the computer. Commands to list files like ls, copy files like cp, move them with mv, and read them with cat. And a fun piece of trivia here, cat actually stands for concatenation, not a meowing animal. Without this folder, you literally wouldn't have any commands to run. So, here's a fascinating question to test our logic so far. If regular users like Alex and John have their personal folders inside the /home directory, where exactly does the superuser, the all-powerful system administrator known as the root user, live? Take a second to think about it. Now, what's really interesting about this is the distinction between the two. The answer is /root. But wait, didn't we just say the single / is the root? Well, yes. And this is a super common beginner mix-up. The single / is the root directory, the trunk of the whole tree. But the folder spelled out as /root is a completely separate branch specifically designated as the home folder for the superuser. It's kept completely isolated and highly protected, far away from the regular users over in /home. And just like the root user gets their own home, they also get their own special toolbox. That would be /sbin. Notice the S added to the front of bin there. That S stands for system. This folder holds all the heavy-duty commands meant specifically for system administrators. Things like fdisk for partitioning hard drives, IP tables for managing your firewall rules, or even just the command to reboot the machine. Regular users generally cannot run the tools inside this folder unless they're granted special permission. All right, we've seen the user spaces. Let's head a bit deeper behind the scenes into Section 3, the System Engine Room. Let's rapidly run through this cheat sheet of system directories. First, /etc. This is where all the system configuration files live. Think of it as the master settings folder for your OS and installed software. Usually just store it as plain text. Next is /var, which stands for variable data. This is your system journal. The absolute most crucial thing here is /var/log, which is exactly where you're going to look when things break. Then there's /tmp. This one is kind of like a sticky note for the system. Programs store short-lived files here that automatically get deleted when the computer reboots, so for sure never put anything important in there. Down the list we have /usr, which, despite how it looks, does not stand for user. It stands for Unix System Resources. This massive directory is where most of your installed applications and programs actually live. And finally, /lib. This holds the shared libraries, essentially plugins and helper code, that those essential commands back in /bin borrow so they can do math, handle files, and, actually run properly. Okay, moving right along to Section 4. Everything is a file. So the crucial point to understand here, the absolute golden rule is this. In Linux, everything is treated as a file. And this isn't just some quirky saying. It is literally the foundational philosophy that makes the Linux operating system so incredibly flexible and uniquely powerful. To prove it, let's look at the /dev directory. In Linux, your physical hardware doesn't exist as some abstract concept hidden away somewhere. It exists as a literal file in this folder. Your physical hard drives, they're files here. Your keyboard and mouse, files. That USB drive you just plugged in, yep, a file. Even the terminal session window you are typing in is represented as a file inside the /dev directory. Crazy, right? And this brilliantly illustrates just how deep that philosophy goes. Here we have two branches, /proc and /sys. These are virtual file systems. The files inside them don't even actually exist on your physical hard drive. The Linux kernel just generates them on the fly. /proc gives you a live window into your running processes and system state, like checking your CPU info. And /sys exposes live information about connected devices and the kernel itself. System administrators can actually write text directly to some of the files in /sys to change hardware settings on the fly without ever needing to reboot the machine. It's literally like having direct access to the system's brain. Which brings us to our final stop, Section 5, Storage, Software, and Boot. Now, because there are no C or D drive letters, we have to use a process called mounting.
Mounting is simply taking an external device, like a secondary hard drive or a USB thumb drive, and literally attaching it to a specific folder somewhere on your Linux file tree. Once it's mounted, you just click into that folder to see all the files on your USB. It completely and seamlessly integrates outside storage right into the main trunk. So, where do we mount these things? Well, Linux provides two primary folders for this. We have /mnt. This is the traditional, old-school place for system admins to manually mount large hard drives or network storage. And then we have /media. This is the more modern approach used by the operating system to automatically mount the removable things you plug in on a daily basis, like CDs, DVDs, or USB thumb drives. Next up, we have a very handy folder called /opt, which just stands for optional. When you install massive commercial third-party applications, think big video games or software like Google Chrome, they often install right here. Instead of scattering their thousands of files all across the /usr and /lib directories we talked about earlier, they drop everything into one neat, self-contained package right inside /opt. This makes massive apps incredibly easy to manage and delete if you need to. And finally, the directory that brings the whole shebang to life, /boot. This directory holds the literal Linux kernel, the actual heart of the entire operating system, along with the bootloader files required to wake the computer up when you press the power button. Because these files are so incredibly critical, the absolute golden rule of the /boot directory is do not mess with it. Seriously, if files in here get corrupted or deleted, your system simply will not start. Let's take a step back and see how this all builds into the complete picture. Look at what we've mapped out together. We started with that single /, the root trunk. From there, we found the user spaces and essential tools in /home and /bin. We dove into the engine room with configs and resources in /etc, var, and usr. We discovered that hardware is really just virtual files in /dev and proc. And finally, we saw how storage and startup are handled in mnt and boot. Everything has its specific, logical place. And that brings us to the end of our explainer. I really hope you can see now that getting away from those scattered drive letters and moving to a unified, clean tree structure is actually a massive upgrade in organization. It makes perfect sense once you know what the branches do. So I'm going to leave you with this. Now that you have the map of this unified tree, which branch of the Linux file system are you going to jump into the terminal and explore first? Thanks for joining me on this tour, and keep on learning.